Okay guys, so if you've never had me before, I just sort of do a quick run through with all of the work of the review packets. I don't expect you necessarily to keep up as quick as I'm going, so if you need to check something or rework it out, just remember you can rewind, you can pause, you can do any of those things. I won't talk through every step of every problem, but I will show work as I'm going through. So just stop or press pause if you need a moment to sort of catch or write down work. And make sure that you're doing okay. So number one, we're just finding the GCF. So if we look at 24 and 26, x to the fifth and x to the third, right? We want a number that will go into both of them. If they both have the variable, we pick the smaller exponent. And once we're here, we don't have anything else in common. So we know that this is our GCF. Oh, that's a 3, guys. Sorry. That's a 3, right, is our smaller one. If we did have multiple ones, we would have to multiply. Man, that's not a good way to start the video. Number 2, prime factor, we're just gonna split this up. Remember, we're going as far as we can. Anything without a branch. So 5 2s, and then we need 3 x's because there's an exponent of 3. So we would pick B. Option A does have 8 times 4, which would give us the right number, but those aren't broke down into primes, so that's not what we want to pick. Number 3, we're just factoring, so we have to decide what format, so we're always looking for a GCF first. 10 will go into both of them. W to the 6 is our smaller exponent, which will leave us with the W squared plus 4. So we will pick C. 2 is 4 terms. So 4 terms, let's see, we're gonna look and see if there's a GCF. There is not a GCF of all of them. So then we'll split in half for 4 terms. What goes into 18, that also goes into 24. We'll factor out a 6G. That will leave us with a 3G squared minus 4. The right-hand side will have a 5 in common, so that'll be a 5, a 3G squared minus 4. So these two go together in a binomial, so I need a 6G plus 5 and a 3G squared minus 4, which is going to be B. Number 5, if we look for a GCF first, there is not one, so again, then we'll split in half. On this left-hand side, we have a GCF of 3x. Let's see, that will give us a 5x squared minus 2. This marker is dying. And we'll do the other side. That has a GCF of 4. That will leave us with the 5x squared minus 2. So we need a 3x plus 4. Let's see, 3x plus 4 and a 5x squared minus 2. So we will pick D. Number 6 is a trinomial. There's not a GCF, so we'll do A times C, which is 40. Everything is positive, so we want the set that adds up to 13. So we'll pick 8 and 5. Everything is positive, so we will pick A. Number 7, again, a trinomial. 1 times 45 is 45, and we'll make our list. Okay, so we want the set that will add up to 14. Everything is positive. That will be 5 and 9. We can use the shortcut. So again, we will pick B. Number 8, 1 times 100 is 100. See, 6 and nothing, 7 and nothing, 8 and nothing, 9 and nothing, 10 and 10. I just skipped writing those down so I wouldn't run out of space. We have a subtraction here, so we need both negatives. So we'll pick -10 and -10. Now be careful with this because it's tempting to go here, but we want both negatives. And remember that exponent of 2 is what tells us both negatives. So we will pick A. Number 9, no GCF. So 10 times 14 gives us 140. So you're going to have to be kind of consistent and stick out a list here. So 1 and 140. Let's see. 35. 28. So 6 is a no. 7 is 20. I'm just checking my sets just like you guys would. 8 doesn't work. 9 doesn't work. 10 and 14 works. 11 will not work. 12 doesn't work. 13 doesn't work. So we're done. All positive. So we need a set that will add up to 39. So we're going to pick 4 and 35. This one we cannot use the shortcut. So we need to rewrite it into 4 terms. So 10x squared plus 4x plus 35x plus 14. Then we'll split in half. This has a GCF of 2x. Over here we have a GCF of 7. So we need a 2x plus 7 and a 5x plus 2, which is A. Number 10, there's no GCF, so we need 4 times 21, which will give us 84. Again, we have another list to make. So 1 and 84, 2 and 42. Let's see, 3 will work. 2, 3 and 28. Pretty sure, let me double check. I'm not, yeah. 4 and 21, 5 and nothing. 6 and 14. 7 and 12. 8 and nothing. 9 and nothing. 10 and nothing. 11 and nothing. So this is our list. We need 20. So 6 and 14. Again, this one has to go into 4 terms. So 4y squared plus 6y plus 14y plus 21. And then we'll split in half. We have a GCF of 2y. So 2y times 2y plus 3. Over here is 7. So we need a 2y plus 7 and a 2y plus 3, which is C. 11 is a special case. It's 2 terms. It's subtraction. 7 times 7 is 49, and we can take half of the exponent. So 1 gets addition and 1 gets subtraction. Same thing on 12. It is 2 terms. We can take half of the exponent. 8 times 8 is 64. So we need a k plus 8h and a k minus 8h. So it's going to be B. 13 is the same thing. 9 times 9 is 81. 5 and 5 is 21. So a 9b plus 5 and a 9b minus 5, which is C. 14. Do we have a GCF? The answer is yes. This has a GCF of 2x. Let's see, 4 does not have any multiples that add up to 2. So our best option is going to be A. 15, we're just filling in the missing piece. And the nice thing is here, it tells us one of them. So we just need to know -9 and what. So if you just do your -135 and you divide it by -9, right? 1 times -135, and we know we need one of the numbers to be -9. So -9 times what is -135? It's 15. And if we double check, -9 plus 15 gives us the 6. So we want C. 16, we want all of the possible answers. So GCF is 2. Then we want pairs of -6. that add up to positive 1. So it'll be 2 times an x minus 2 times an x plus 3. Okay, so we know option B will work. Okay, if we look at D, we have an x minus 2 here and then a 2x plus 6, so D will work. We have an x plus 3 here and then a 2x minus 4, so this will work. And here our sign would be wrong. So those are all the options we should circle. C is not an answer. Okay, 16. So we want multiples of negative 16 that add up to 15. Our sets are going to be n plus 1 and n minus 16. You can make your full list. 18 is a special case. 10 times 10 is 100, so a y minus 10 and a y plus 10. 19, we want factors of negative 54 that are going to add up to positive 3. Make your full list, but we're going to get down to a 6 and a 9, where we want that to be negative. So we can use the shortcut, a y minus 6 and a y plus 9. 20 are sets of 4 that add up to negative 4. We'll want both negatives. So you can either have this as a y minus 2 times a y minus 2, or you can just write it as y minus 2 squared. 21. Let's see, this has a GCF to start with. I'm sorry. So we can pull out a 2. We can pull out a 6. 3y minus 6. Plus 2y squared minus 4y. Then we'll split in half. GCF here is 3. GCF over here is 2y. So we'll have a 3 plus 2y, a y minus 2, and then we'll also have the 6. 22, we'll take 2 times negative 20, which is negative 40. All right, you'll make your whole list. We want our larger ones to be negative, so this is our set we're going to pick. This one we have to rewrite into 4 terms. I'm going to sort of write it above. Plus 5c minus 8c minus 20. Here we'll have a negative 4. So we'll get an answer of c minus 4 and 2c plus 5. 23. 3 times 4 is 12. We're going to use 2 and 6. So again, 4 terms because we can't use the shortcut. Split in half. So we'll get a 3x plus 4. 24. It is subtraction, but it is not a perfect square. There is no GCF. 24 is prime. 35, we have a GCF all the way across. Then we can split in half. So we'll have an x minus 1, an x squared plus 4, and then we also need to use that 3 in front. 26, 2 times 10 is 20. We want both negatives, so negative 4 and negative 5, so we'll say 2a squared minus 4a minus 5a plus 10. Do a negative 5. So we'll have a 2a minus 5 and an a minus 2. Okay, so next page, number 27, again, a trinomial, there's no GCF. So 1 times negative 42 is negative 42. Okay, sorry, you'll kind of notice there was a weird jump. It was the end of my lunch. I had to finish the video in a different location, so sorry about that. Okay, so we'll make our list. 1 and 42, 2 and 21, 3 and 14, 4 and nothing, 5 and nothing, 6 and 7. Remember, when there's no number here, there's really a 1. We want it to be 1 negative and 1 positive and add up to a positive. So our larger number is positive, our smaller number is negative, right? We always want the right-hand column to be the same thing as B if we need one of each. We want it to add up to 1, so we'll choose negative 6 and 7. This is a shortcut, so we'll have an x minus 6 and an x plus 7. Number 28, we say, is there a GCF? The answer to that is yes, so we can pull out a 2. Okay, then we'll look inside the binomial. The x squared minus 16 is a special case, right? 2 terms, so we check for a special case. 4 times 4 is 16. So we'll get 2 times an x plus 4 times an x minus 4. 29, is there a GCF? The answer to that is no. So then we'll count the number of terms. There's 2, so we'll check for a special case. 5 times 5 is 25. 8 times 8 is 64, and we can take half of those. So we'll have a 5x plus 8y. Here, I'll write it over here actually. So a 5x plus 8y and a 5x minus 8y. Number 30, is there a GCF? The answer to that question is no. So 4 times negative 15 is negative 60. Make our list. Seven and nothing. 10's already up there. We need our larger number to be positive, so our smaller one to be negative. And we want 17, so we'll do 3 and 20. Well, negative 3 and 20. We cannot use the shortcut because A is 4. So we'll do a 4x squared minus 3x plus 20x minus 15. And then we'll factor by grouping. So our GCF is x, 5. Right, so these go together, so we'll have an x plus 5 and a 4x minus 3. Okay, then we have our free response, number 31. So if we want to explain how to factor this, we need to make sure we're doing all of the steps. So step number 1 is that we're talking about, you should be writing out in full sentences, but in some way, shape, or form, we're talking about looking for a GCF. Okay, and that this one does not have one. Step 2 would then be something about how you're counting the number of terms. So if we count the number of terms, we would say 3 terms. So then we're going to look for a trinomial. Right, so we're doing something about this and it being 3 terms. Okay, so we're multiplying A times C, which gives us 30. Okay, so we should be talking about how we're getting 30. We're looking for multiples of 30 that add up to 13. Okay, so you should be talking about how you can pick 3 and 10. So the next step that you should be talking about is that we'll find the set that adds up to B. Okay, and then how we'll rewrite it into 4 terms. Don't just say you're then going to do, factor it from there. You're then going to have to explain that. So then you'll have to say something about how once it's in 4 terms, right, you'll split it in half and find the GCF of each half. Okay, and then you'll be saying something about how you rewrite it into 2 binomials. Or write 2 binomials or whatever, right? You can sort of explain that exact wording, but these are all pieces you should be talking about. Okay, number 32, Sally factored the following: x squared minus 25. She got an x plus 5 and an x plus 5. Explain what she did wrong. Okay, so when we're factoring a special case, we should be talking about the fact that these shouldn't both be plus 5s and that this is a special case. And that we need one with an addition sign and one with a subtraction sign. And then we get to our last page, our review portion. Okay, so number 33, when we have that exponent of 2, we should be writing it twice. And then we should be distributing this out, right? Our double distribute. Okay, so the length is 4 feet longer than the width. So our width will equal W. Our length will be 4 feet longer, so that's addition, right? So this is now our rectangle. Okay, so perimeter says to add up all the sides. So we have 1, 2, 3, 4 W. Plus 4 is 8. Equals 22. 7 over 2, let's see, 3.5. Okay, so if our width is 3.5, again, it needs a label of feet, then 3.5 plus 4 would be 7.5 feet. So our width would be 3.5 feet. Our length would be 7.5 feet. Number 35, these are already stacked, so I might solve by elimination. I'll make those y's match. Right, the two things are matching coefficients and an opposite sign, and then we can add these. We can get fraction answers. Fractions are our friends too. We're gonna take that and plug it back in. Let's see, I think I'll plug it into the bottom one. So if you feel uncomfortable with that fraction going back in, use your calculator to help you, right? Do 3 times 10 ABC 11. Subtract this 30 elevenths. Let's see. Again, you could use your calculator to do that math. I just can do it without it. So let's see. 14 elevenths. And then we will divide by 2. So we'll get 28 elevenths. Oh, no. That's not right. I'm doing my math too quickly. So it'll be 14 over 22. Let me check that. Ah! Yep. So 14 over 22, which will then reduce to 7 over 11. So our final answer will be X is 10 elevenths and 7 elevenths. Number 36, we undo, here's that work, guys. I'm sorry, I think I got a little bit too low. So there it is, so you can see it. Number 36. When we divide by negative, we have to flip that inequality sign.